So, welcome to our next talk, how environmental friendly is software. You probably know that software is a lot of resource hungry thing and doesn't run well on older hardware. So browser and games don't really run well. Green IT is something that's a lot of being talked about and people think about it quite a lot, and there's a lot of research on how can these things go together and work together. Two things about this is first research, second certification. So there is a certificate of what is sustainable software. And we do have two fantastic speakers right here, which are going to talk about this. This is Marina Köhn. She is a computer scientist and has been working as a programmer for a lot of years now. For 28 years, she's worked at the Umweltbundesamt, which is the Federal Office for Environmental Issues. And there's Dr. Eva Kern, working in Büttenfeld, and please give a big hand for first speakers. Yeah. Thanks for inviting us. We're really excited about this, and it's a lot of people that we didn't expect that. We thought we would have a small group here, but it's really exciting for us. So, yeah, so that was a very, very pleasant greeting that we received. And yes, now we're talking about protecting the environment, conserving resources, but what we shouldn't confine is the resource of knowledge, because knowledge multiplies if you share it, and that's what we would like to do. So we would like to share our knowledge and our insights from our research. We do have this agenda here. So first I would explain why we as the Umweltbundesamt have this topic at all, why we are talking about this. So what's our concern there? Then Eva is going to talk about our research results, and she is going to present a lot of interesting results of measuring software, actually. Be excited about that. I like her talk, so I am always keen on listening to this. And as a closing, I'm going to explain the blue angel, der blaue Engel in German, because we try to apply what we have found in research, and with as the seal from the Umweltbundesamt, this is the blue angel, and I'm going to talk how we're going to proceed. So the backgrounds and the motivation. You see, you know this image on every event that there is a lot of mobile devices being held in the air, and you know, and I know, it's not only technology, it's not only hardware, there's a lot of software going on in the background. A lot of people, when they stream or record a performance and they send it to their WhatsApp group, that they actually multiply data. So the consequence is here. I'm going to show you the newest numbers of the Bundesnetzagentur, Federal Office for Network Infrastructure, and you see we see a very, very strong rising tendency of the data volume that's being shared. It's actually doubling every 2 years. And you know, if you think about your bookshelf at home, and every 2 years it was double, that's what's happening with data. That's what's happening right now here. So these data have to be stored, they have to be shared, which happens at server farms, at computing warehouses, and that means that the demand for computing resources is rising and has been rising. And we do know that we have to expect a very, very strong, even dramatic increase. So our colleagues from Scandinavia have some prognosis here, some looks into the future. And if you look at the green curve, then you can really be afraid, because there's not only more demand, it means we have an extreme increase in power consumption and in rare metals that we need for the production of servers and chips. And we would like to stay on the blue line. So that means that on all fronts, not only in the computing warehouses, that we need to be more efficient regarding software. Energy consumption does not only happen in server farms. It also happens in decentral computing setups. So you might know about Bitcoin, and that Bitcoin mining just consumes a lot of energy, but if you think, so you might know that Bitcoin mining takes place in China, where the power is made from burning coal, and that means when we need to reduce our carbon footprint, then that's a development that we cannot say that's okay. We have to say, like, at least, is there a more efficient possibility? Is there something that Bitcoin mining is connected to the price of energy? So the lower the price, the higher the gain I have from Bitcoin. And Bitcoin mining takes as much power as the country of Austria. That's not peanuts, that's a lot of energy, and that's what happens through software.
So I brought an example here. We just talked about how software contributes to the power consumption, but it also contributes to hardware becoming obsolete. So as an example, here is Windows, and how much memory capacity Windows needed in the start, and how much processing power. And then we compare it to Windows 10, we can see that there is a very heavy development that happened. I can see right there in the back, yeah, I mean, Windows 95, a lot happened since then. Windows has become a lot more powerful. But yes, but if you see the Windows XP row, you can see that Windows XP could do with 1.5 gigabytes of hard drive space, and Windows Vista already needed 15. The same with memory. Vista needed a lot more memory than Windows XP, and that didn't. And I assume that didn't linearly grow with the feature set, but it's product of software blow up. So a couple of years ago, when I had a spreadsheet program, I could just use it to calculate things, and nowadays I can edit pictures with it. And now we have to ask ourselves the question, is that even necessary? Do we need more and more complicated hardware for more and more complicated software? So, in summary, on one side we have the problem that software contributes to more power consumption. Of course, not the software itself uses the energy, but the hardware uses it, but the software sends the commands that make the hardware use the power. And if I write the software more cleanly, then it uses less power. And by writing more efficient software, I can also make hardware be sent to retirement less early.
If you think about the rare metals in our devices, we have very, very valuable devices here. Thinking about data formats, about distributing data, that's also a problem. And the question is why politics has not reacted on that. Well, they did not, because it's very, very much more difficult to regulate software than hardware. So a law on, if you think that there is regulations on hardware, who knows the EU design regulations on hardware? It's about 10% in the audience normally know about this. Most people don't know about this. There is a law that regulates its computers, TV devices. They have to have a certain level of energy efficiency, or they may not be sold in the EU. And that's why in 2012, computers and notebooks have become much more efficient. But sadly, this does not happen in software because it's much more difficult to do. I have a couple of cutouts here of the scandals that we had in the past months. So a setup box doesn't go to power consumption mode, printers don't work. There's no more updates for all the systems. You know about this. Well, that's the background why we say, well, we have to do research here. We have to do some work here. We need to find a method that the impact that measures the environmental impact of software and assesses it, so that we can formulate boundaries that we would like to have on software, and finally arrive at some criteria that are measurable, that are verifiable to have environmental and sustainable software. Now, I would hand it over to Eva, who is going to present that area and present what her team is doing and some beautiful results. Yes. So, at the Umweltcampus Birkenfeld in the near Trier, we are researching on green software. What is green software? Well, we didn't know in the beginning, and now we also do not know in detail, but we were thinking about, well, what is software? It's what drives hardware power consumption. So here is something to make it more palpable. Here's a graph. So the software doesn't have a cycle on its own, like producing, development, using, and then uninstalling it. So that's the life cycle of a software product. It also has impact on the life cycle of hardware. So hardware is being produced, it's being used, and then it's being disposed of. And software is actually using the hardware, but it's also defining, can hardware be used or can not be used. So how can we make it more lean? How can we reduce the hardware resource consumption? And, well, in the end, that has something to do with the environment, because the hardware lifecycle is connected to the environment, and we want to reduce the impact that hardware has on the environment. So we wanted to look at the concrete mechanisms. How does it work? So we didn't only do it graphically. We were looking at, okay, can we develop criteria that could tell me, is a software environmentally friendly or is it not? So to make it palpable, what are the effects of software on environmental issues? So the first question is energy consumption, of course, but the other thing is also hardware consumption. How much hardware is being used and how heavily is it being used? And we were trying to come up with a method how we could get a grip on this. And the method is a three-step process. So first, what we do is we look at the product, and then we see, okay, what can it do? What are the functionalities of the product? What does it do? And what is the most common use case for a product? And then we have the standard usage scenario, in German Standardnutzungsszenario. And then, so that's the scenario, that's the common usage scenario, and that's what we can measure. That enables us to do step number 2, that is actually measuring. We go there, we record the standard usage scenario, so we have a software that executes certain functions, and then we measure the energy consumption and the usage of the hardware, and we record that and those data so that we can analyze it. So first we have the measurements, and on the other hand, we also have data that are, for example, in the documentation, in a wiki, in a handbook, or so that we can analyze the software product as a whole. In step 3, we analyze it, and we came up with some indicators, and then we just try to measure and figure out, okay, how well does the software do with those indicators? And we would like to give feedback to the users as well as to the developers to show, okay, where is potential for optimization, where is potential for to get more awareness. So what we want to do is also some awareness raising. So how does the thing look? So for example, there is a standard user scenario for text processing for browsers, content management systems, and databases. And well, that's nothing surprising here, because we would like to have the core functionalities that are typically used in the software. So if I use a word processor, I edit text, I have something like a table of contents, I would like to adjust the view, and then I would like to save and export it. So that's the common usage scenario that we have looked at for certain product groups. So what does a certain standard user do? So that's not a person that only uses one part of the software. We would like to have the usage scenario using a couple of the very typical functions. So here's a standard user scenario of a media player. So nothing surprising here. So I open the video. I might switch to full screen mode. I might skip forward and backwards in the video. Might even change the speed. Then I go to standard speed. Then I close the software. And if we do this by an automated scenario, that takes about 8.5 minutes, because we need some time where something is actually played in the media player, and where we can actually look at the certain parts and components. Well, how do they use hardware? How do they consume hardware?
Okay, so regarding how it's measured, how does this actually look? So in Bittenfeld we have a small laboratory that we call the software laboratory, where we have a workload generator. So that's just one computer that just replays the user scenario, and then it's automated because we want to redo it multiple times, so we can eliminate measurement errors. And then this is all played on a system under text, which is just a normal PC, which processes the work. And then on that we can measure how much power it uses. So there's a measuring device on there to measure that, and then there's another measurement software that analyzes which hardware components are used. And then this generates an energy efficiency report, which can then be analyzed by the developers to see what the energy efficiency of a specific piece of software is. So this is, for example, what one of those evaluations looks like. So there are results of various product groups. So this is a media player. When it started, for example, there's a big spike and uses a lot of energy, and then when a functionality is switched, it also uses more energy in a small spike. This can be seen because it's exactly measured when everything happens, so we can correlate those things. So one single example doesn't really help us a lot to see differences, so that's why we have a second media player that we measured the same thing with, to see the progress of the energy usage, and we can see that's pretty similar, and that's why we used multiple video players to analyze the results. And so in conclusion, we have the watt hours used by various media players in comparison. So there is one media player that used 0.833 watt hours, and the other one only used 0.479 watt hours, even though they did the same thing. So that's one thing that we could see in the energy usage. But we could also see how the processor usage and the memory usage varied and was in total consumed. So the same functionality with different software used resulted in very different results. So we also didn't just develop the measurement method, but we also developed some tools, because if only we do it in one small laboratory, that's not that helpful. So we created some tools that enable other people to measure these factors, with the idea that maybe in a software development process people have the possibility to measure their own software to work as energy efficient as possible even during development. So one of those tools is the so-called Oscar, which is a measurement platform where you can upload the data. It's programmed in R, and it will analyze the data that comes out of the measurement system. These are, for example, the details, which is maybe a little too much to explain now, but as an example, all of the statistical data is used here and provided in a nice format. And then there's a secondary tool, which is a Excel to XML tool, which enables providing the data in a better format. So this is not only available for text processing and browsers, but also for other software, and we are still working on enabling more different software. So we've looked into sustainability management softwares, and because we thought it would make sense to look into those tools themselves because they're kind of related to the topic, and so we want to maybe contribute to how those kinds of software. We will also look into image processing, we will look into web shops, and we will look into PDF viewers, and we're on those to validate our methods for the future. So what we also saw is that there are three main influences for the measurement results, which is for one, the kinds of software we used, which is also dependent on the reference system. But yeah, as we saw earlier, when we look at different kinds of software, we see very different kinds of energy usage profiles. And depending on the kinds of software used, with, in this case, 2 different text editing programs, we can see very different energy usages. And here again, we can see that the work process, the energy used, again varies, and we again saw what were the influences, the kinds of software, what software used did have an influence. The next one is the common usage scenario, and again we saw that it again makes a difference how the software was used, whether we wrote something or we just looked at a page in a text editing software. So all the methods have to be observed critically to see what kind of influences actually influence the measurement results, to see if to lessen the errors in the measurements. Again, in the results we can see that writing in a text processor consumes more energy than just looking at it in reading mode. The last one is the reference system. So the reference system is what we call the program where the environment where the program is executed, what computer we chose for various criteria. And we can see that on this device is where the software is running, and this is also an influence onto the energy usage. And we can see the various influences that we see. For example, for various reference systems, there may be various energy usages. Again, in the measurements we can see that for different systems, and if the reference system is older, then the differences are usually higher. And we wanted to develop a method that is as solid and valid as possible, and that's also and those are these 3 influence factors. So, for example, this one is for text processing again. We have a usage scenario that we thought of, and measured 2 different text processors, and measured and looked at the spikes in power usage, and got for the same usage we got very different power results. And then again, this in conclusion for the differences, because we often get asked, does it even really make a difference? And yes, these are for singular environments very small differences, but when you think about how many text processing softwares are used for longer than 10 minutes every day, then we think that there is an approach there to look into improvements, to look further, to see how we can develop differently so less energy is used, and also provide and create transparency, because this is an important part, and that's why we worked on creating a certificate for this.
Yes, before I do that, I would like to get back to that slide that shows this fact. So here, wrong direction. So yeah, so regarding word processing, we have looked at it and if you go back one more, you can see we at some point we stopped measuring, and you see we looked at what happens afterwards. And if you look at this up there, you see that there's you have a nice baseline. So for someone who does energy consumption measurements, that person loves baseline. So something where you always get back to like the background noise. So you don't see this in the lower part of the picture. You even think the baseline is up there. And now look at the point when we saved something. They just kept watching, and you see the software at the top. After saving, it's quiet. If you look at the software below, it's still moving. We don't know what it does. Maybe it's phones home or something. We don't know what it's doing. So a developer can recognize, okay, what is happening there? And we had this one point during the research that was curious to me. There were some very, very enormous peaks. So what was happening there? Could you tell me what it was? I don't know, the blinking cursor. Yeah. So the blinking cursor in a software program took a lot of power, it soaked a lot of energy, and there is actually a faulty library, and the library has not been changed, and now we have quicker processors, and it still peaks when the cursor blinks. And we want to get attention from the people in the room, people who develop software. These tools are free, so take a look at them and take the time to do more efficient programming, and think about, okay, what libraries do I use, and are they still efficient? Maybe there's more efficient libraries for using that. But now, for my part, so I would like to introduce the Blue Angel for software. So if I just said, yeah, well, we took more or less a year, but not so long as we projected, because it gave us a really solid base, so the research work that they did. So the idea is, or the goal of the Blue Angel certificate is, we would like to certify software that's very efficient on the hardware and doesn't use as much of the hardware, so that even old technology has a chance of running the software, and also that energy consumption is low, as low as possible. And so these are the goals that we had at this point. The Blue Angel symbol, if you've been to a hardware store or so, bought some paint, you have seen the Blue Angel symbol. You have also seen it on the toilet paper. And there's also Blue Angel symbols for computers. There's going to be Blue Angels for servers and storage technology, and there's also a Blue Angel for data warehouses. And starting next year, there's going to be a Blue Angel for software. So the Blue Angel doesn't want to set a standard, it wants to certify the best of the best. So we have very, very ambitious requirements for that. Because having high ambitions, that is a quick thing to do, but how do you actually test that? So that's what we tried, and we think we succeeded. We found a couple of indicators that that we can check on software, and a couple of them we could use for the Blue Angels. So before I show the criteria, I would like to explain how the procedure for the Blue Angel works at the Umweltbundesamt. So we are the institution that develops the criteria, that's strongly connected to research in almost all cases. Next thing we do is that we present the criteria to the public, and we would like to have discussions. So we have this experts round table. Everyone who would like to can participate. Of course, we invite people. We invite people who are using this, who are developing the software. We are talking to open source people. We're talking to people from the industry, and then we discuss the criteria, and we also discussed our minimum requirements that we have. Then we have the jury for the Umweltzeichen, for the Blue Angel sign. There is a couple of actors from the society in there. So we have churches in there, we have environmental conversation groups, we have people from representing the cities in Germany, and they decide whether to have the certification or not. And so this fall we could convince the jury that this is a useful thing to do, and now we can go forward with the Blue Angel certification for software. So what's the criteria? So as I said before, resource efficiency, that's a really, really important thing. So energy efficiency and using and making use of the hardware, that is something that's important to us. Second point is, how long can I use the hardware? So the life cycle time actually of hardware. So when do I have to retire a device because the software is not lean enough? And the final criteria is we would like to have an autonomous user, so that the user can decide which module would I like to use. Can I switch to a different software product at all, so that he's not tied to a certain product, so that there's no vendor lock-in at this point, waiting for updates, for example. And is it possible to actually completely remove the software from a device? Sounds easy, is not as easy in all the cases. So here is the criteria. I'm not going to go into super detail here, but it's already published, so you can read it, but I would like to show you a couple of those. So what we would like to do is, we would like to have measurements for all the time. So the usage contract that we have goes until the end of 2020, and we don't expect just measuring at the beginning and then having just a protocol of that. We expect that the software consumes less and less over its life cycle, and we expect then when the software is being updated, then we don't have more energy consumption as the software matures. So, and there's also a list of reference systems with the Blue Angel, and people who want to get the Blue Angel certification, they have to prove it runs on 5-year-old hardware. So transparency is also very, very important. So that regards interfaces, data formats. So we do expect that a user is possible to communicate with other software products if the software is designed for that. What we would like to have is modular software. So the user decides, do I want to have image processing with my spreadsheet or not? So the user should have the autonomy to decide, I want to have lean software. We don't want any advertisements in the software that is not necessary. We do not want to have any uploads of phoning home. So software containing ads is not going to be certified. And finally, we have this final evaluation, and then you have to prove that the software actually has improved over the time, and what measurements you did take as a company or as a developer to actually improve the software on these criteria. And now there's, that's something we were not super happy with this, because we had to restrict very, very much enough as to which software we could use. So we could only include desktop software, while knowing that a lot of software is running on servers, is running on the internet. So either we would have to be very arbitrary with the criteria, or we could have very demanding criteria on the desktop. And so that's why we proceeded this way. But I can make the promise we're going to continue. We're not going to wait. We're not going to wait until the research or until the certification is done. We are going to include more and more software types in there. Another thing is there is not going to be a Blue Angel for shooter games or games. So we're going to certify games, but we are not going to certify games that promote violence. These are not going to get the Blue Angel certificate. So what are we going to do next? So we would like to have minimal requirements for the energy efficiency. So we are measuring right now and getting some ideas. Can we actually formulate can we quantify the number that we would like to have? We would like to enlarge the types of products that we can use and the scenarios that we can do. And there's also this idea of having labs, several labs who can do these certifications. So we'd like to encourage people to install a certification lab so that people who would like to gain the Blue Angel, that they can actually have a certified lab that can do the measurements. So that's it on the Blue Angel and software. That's what Eva and her team and we did, and that's the research. And the Umweltbundesamt is also continuing on this. So alongside the energy wasting of energy, we have another topic that is very, very pressing for us. I've done this in 2000 already, and that means the interdependency of software and hardware, so that the software actually regulates when hardware needs to be changed. But now we have household tools that are run by software, and products which used to be usable long-term, now are short-term products you have to throw away because there's a software update that is not possible or that is not changeable. So there is going to be a research project that we are going to start in, that we have started in this year. And I've seen a couple from our research team, so could you just stand and just wave? And please ask those if you would like to talk about this topic. So we know it is a problem. We would like to talk about how can we have criteria for a law so that we can have actually a European law for the eco-design law that says, okay, when there is hardware, there is minimum minimum requirements for the software. Okay, so that's it. So there is a possibility for questions, but thanks a lot. And thanks for listening to us. So we are going to use the break to just say hello. These were your translators. That's F.L. Berger, Oscar, and Ian. And now we go to the Q&A.
So, thank you for the talk. We have a lot of time for questions, so anyone who has questions can line up on the microphones. So, anyone who wants to leave, please use only some of the doors. Okay, let's start with a question from the internet. Okay, so a user is asking, did you look into how the energy usage changes when the whole tracking that is implemented into modern operating systems is included in the measurement? So for example, in Windows 10 there are lots of tracking mechanisms.
So we haven't looked into operating systems yet. What we did was we measured to find out a basis upon which we can distribute that data carefully onto.
Go to microphone number 1. Thanks for the talk, was very interesting. So I want to be thankful and not complain, but so it's all consistent, but it does only get into a few areas. A lot of the energy usage happens in the cloud, and not, even though I think that we should use our own computers more, I am wondering whether you're planning to get into cloud systems more and look into those. Look into virtual machines and containers. What's the energy usage of streaming? What are the looming goals for saving on energy in these areas? Are privately used computers that more and more become less relevant, and mobile devices that are technically very energy efficient, but offload more onto the data centers? Will you look into that more? That would be interesting and probably also easier to regulate. Maybe a shorter question would be better.
So indeed, yeah, we will continue on in that area of research. We will invest more research into that as well. We have invented technologies to regulate the efficiency of data centers. We are in discussion with the responsible people in that area, but we will not be able to measure all of these products inside of this Bundesamt. There are other products which are definitely better. What we want to do is enter discussion. I would be happy to see the intelligence inside of the IT branch to make software more intelligent. We are very far away from efficient devices, even though people are of other views. That isn't really correct. Do not listen to that. We did measure that, and we do know that computing centers do have a computing requirement of 15% more than would be necessary. What we do want to do is, together with other professors from other universities, we want to form groups
So we would have professors that form groups and that do actual research to have it in a study curriculum, so that people, even when they're studying it, have the knowledge to build software. So we're not stopping that.
Okay, let's go to the next question. Not only ask short questions, but also get closer to the microphone. Next question from the internet. Okay, so the next question is more into operating systems. You already said that you did not look into those, but did you think about doing that in the future? Because the same text processing software on the Windows and Linux probably has a different energy usage.
Yeah, you know, we would like to do this, so this is something that we would like to do research on, but right now there is no going to be a Blue Angel for operating systems. There's too little of them. So if we do something, and you know, the Blue Angel certificate is a lot of work, then there's the question of the jury, well, is there enough people who use that, or people who do this? So we're going to research that, but in another area. And what we looked at is software that is running on several operating systems, but we're not that far to have any palpable evidence. But of course, we do know that software consumes differently running on different operating systems. So we are aware of that, and we're working on it. So there was a talk on Bits and Bäume, so that free software is not automatically more energy efficient.
So 25 years ago, Niklas Wirth from Zurich wrote on the software explosion. So the English apply, his English apply is still findable on his web presence. So my question is the criteria for the Blue Angel, will that influence what, for example, state agencies will buy in hardware and software? And what, how does this correlate to the Digital Pact, where a lot of money is spent on devices for schools and similar institutions?
Well, we are a scientific state agency, but what we can do is that we have some impact on politics with our results. And what we could do is that in the administration, or the federal administration, that the criteria have to be observed when buying hardware for federal agencies. That's a start, but next year, yes, it's actually next year, then we're going to have the discussion with the federal states of Germany. So I'm going to talk to some representatives of them, and that is one thing. So because the pressure is increasing, which is makes us happy, at the federal or at the federal state level, when people buy hardware there, yes, we can do something, but I have to say that we since 2008 we have a Green IT initiative on the federal state level in Germany, and we have reduced energy consumption by 40%. And people from the industry, they glare at me when I say, well, you always say you are the best of the world, but you aren't. Can you just prove it? Because we can. And there's a lot of work to do right there. But there where we can have an impact, we try hard, and we also try at the European level. Yes, and I will have something more. So I work for member of the Bundestag, and that's really, really hard to do. So there's another question.
Okay, next question. So, as far as I understood, the efficiency is mostly focused. So your research is mostly focused on software. So, but efficiency is not only about how much less energy is used in the end. Because when you looked at the video players, when they get more efficient, then maybe they implement higher resolutions and use more power again. Is this observed in your measurements in any ways? Because computers have become magnitudes more efficient.
Well, yes, exactly, but it's difficult to measure this rebound effect. I totally agree. So in the moment where something gets simpler, we have this rebound effect. So you don't have to actually drive to a video rental. You can do a contract, and then you can stream videos for the whole day. So making things simpler has dramatic increases in energy consumption. And yeah, so the only thing that we could do up to now is to measure the life cycle of the products that are involved, and that we say, okay, the software has to run on 5-year-old hardware. So that's the first and only thing we can do. You're absolutely invited, if you have ideas, to work with us. We cannot know everything. And since we started 2012 or 13 for the first time, so back then, there were 3 people when we had the first discussion with the industry. So that was really, really difficult to get researchers, to get interested persons. It has changed, but when we had the jury discussion for the Blue Angel, the room was packed in a way I haven't seen before. So for the first time, there were new faces in there, and I think that the topic needs time. Maybe we need other criteria, but we're not stopping. So if you have a good idea, then yes, please talk to us. The address should be on the slides. What we also do is the energy consumption over time. So while you have the Blue Angel certification, there's a limit of 10% of increase of the energy consumption of your product. So that's what already was on the talk. You have to measure all the time while you have the certification. You have to measure every update, so that you can actually prove the energy consumption does not increase by more than 10%, and also to talk about why it has increased at all. We have not presented all of the criteria, so that was one idea why I said, okay, now fun is over. We talked about the European level. We have the power management that has to be active on computers, and there's software who actually disables the power management of computers, and there's a lot of more software products of that. software products that are on network, they expect the computer to be always on. Well, as a developer, you know, we have to think about if that's actually a good idea, or if don't we have a better idea for that, so that a computer can switch to low energy mode and still retain data.
Okay, another question from the internet. Does open source software have the possibility to get a Blue Angel if there is no heuristic person there?
Yes, of course, that's possible. We have did research on that. We have some lawyers who check that, and we have good connections to open source developers. If all criteria are met, then that's not a problem.
Another question. So regarding the energy measurements, so because we have a project for measuring electronics as well, so we're working on configurable software measurement systems. And so you said during the energy measurement you fixed some aspects about the computers you measured. And did you also look at configuration aspects, because for example there can be a factor of about 100 for database management systems?
No, we have not checked several configurations. We know that this is happening, but we could not do any research in that. So that's interesting that you do this. I would like to talk to you. And there's probably a lot of people who are going to would like to talk to you. Microphone number 2.
Okay, so if we don't look at things being bought for public entities, is there something that is better for people that buy Blue Angel hardware or software?
Well, that's difficult. You know, the user can actually, when the person buys software, then he can see and is aware of the label. It's on there, so the vendor can actually use it for advertisements. But you know, with all Blue Angel products, it targets people who are very conscious about the problem. There's no more that we can do there.
Another question. So back to desktop computers versus data centers. Is there any approximation for the proportionality between those two?
Well, I have something in the back of my hand. I'm not really sure about it. So it was, I think, half of the power consumption of IT is in the cloud, but don't take my word for it. So we have a lot of desktop software. So people are thinking about Word and Excel, but I'm talking about products that are in-house developments for administrations, and that's desktop software. And I'm also talking about smaller tools. And well, if you think about the carbon footprint, there's a lot of software that's running on desktop. There is a couple of them. And because I have to present that to the jury, that we think about a market, it's not that bad. And so I think it's 50-50 desktop and cloud.
Okay, next question. Did you also certify your own software?
Well, we couldn't, because the Blue Angel is not released right now. But so it has just been decided in December that this certificate is going to be there. So of course we're going to get certified. But it's open source. Yeah.
Next question.
Currently, we use software that is being used a lot in our environment, and we looked at people, okay, how do people use that? Of course, we cannot rule this out because we cannot do measurements worldwide. We have looked for statistics, how software is being used, what functionality is being used, but there's no data on that. So there was this idea how is software being run at the university, but then again it's privacy and data protection, so we could not do that. So we cannot rule it out that our standard usage models do actually not measure the standard usage. But we think the core functionalities should be in there. And with open source software, we actually talked to the developers and we developed together and we talked with the companies. And so we rely on that where the user questions come from for a product.
Okay, next question. So here in Germany, we have this tradition of software cheating on tests. How would you prevent software behaving differently under tests and then setting wrong incentives because the software is locally running less and starts using the cloud more, for example, but then again using more network resources, but still gets the Blue Angel?
Yeah, that's why in the first step we would like only to certify software that is only running locally on the local machine. So because we don't have a usage model for data centers, and so if computing moves to the cloud from software, then we have to think about it. So that means it's only a first step and it's using the local computer.
Are you sure there are no behavior differences just because the device is under test?
Well, there is no fixed lab situation. So what we do is we are checking in labs that we know there is auditioning or there's a peer review on that. If the data is plausible that we receive from the labs. And for example, we have to check whether the software actually runs on a 5-year-old reference system. And that means there's going to be persons who check that. And our procedure is, well, that's not unheard of. We also have it with data centers. There's also a Blue Angel for data centers. And you could tell anything there. So there's reviewers that actually check the numbers, look at the numbers, and that just look at the validity and the believability of the numbers and the measurements of it. But honestly, we have a 40-year history of the Blue Angel, and there has been no scandals in that time. And I think that's something because we are that good, yes, but the other reason is that people who actually want to be certified, they want to prove they are good. So the worst thing would be that they wouldn't be as good as they were when they tried to be certified. So we are the first ones to know when something doesn't work. And so there was a competitor of a data center who was wrong about the Blue Angel, and so there was a case in there, but it turned out to be wrong. And so we have companies that go through our painstakingly process, and it's also not very cheap. It's expensive. And yeah, talking about time, we are at the end of time, so there's a lot of demand for discussion. So let's talk to the speakers now or later. But I think you will have an opportunity to ask questions. Thanks again for the questions and a very, very big hand for the talk. Thank you for coming.